Entering Mathville, please derive carefully. All right, in this lesson, we're going to be learning the derivatives for two trig functions, sine and cosine. Right, so, in the table of values there, right, those are not the values for y equals cosine x. Those are some slope values. All right, but let's see that those are the right values by actually graphing cosine. All right, so we're going to graph y equals cosine x down here at the bottom graph. All right, so actually, yeah, I'll write it there, and then I'll also do it over here. All right, so that thing is supposed to be a theta. All right, so there we have theta, and then this would be a y value, not a slope. All right, so just a little reminder. All right, little unit circle there. All right, so here, right, cosine is x, right? It's the adjacent. All right, so right here it is 1, the value of cosine. All right, as it moves up here, and of course that's 0. As it moves up there, right, that's pi halves. But the y value, the x value is 0, so is cosine. Over here, that's pi, right, and there cosine is -1, because now we're on the negative side. All right, so that would be pi -1. Oops, sorry, that's really small. That's parentheses. And then we keep on going. This is 3 pi halves, and of course x is 0 there, so is cosine. So 3 pi halves, 0. All right, and so forth. And nobody says we have to go in the positive direction. We could go in the negative direction. So negative pi is going to take the same place as pi does, right? So let's graph for, let's get our values for negative pi. Oops, there we go. Negative pi halves, 0. Can't fit those in. Let's put it over here, where I have a little bit more space. And so just to be clear, that's y equals cosine x, so I'll write it above. Right, and then let's move everybody back. Come on, yay, there you go. All right, and then, oops, wrong color there. Let's make our line a little longer. There we go. All right, so this would be pi halves and pi. All right, and so negative pi or pi, all right, that's going to be -1. Negative pi halves, that's the same as 3 pi halves. That's going to be 0. 0 is 1 for cosine. Pi halves is 0, and pi is -1. So let's graph that. All right, so this value is 1, and this is -1. All right, and so this is pi halves, and this is pi, and this would be negative pi halves, and this would be negative pi. All right, so we start off with -1, and then pi halves were 0, and then at 0 cosine is 1, and then at pi halves it's 0, and then at pi it's -1, and then we just keep on doing this. But that's enough graph for us, so let's graph. Oops, I overshot that. My hand blocked me. Oh, that was just me being just missing. There we go. And then it would just continue doing the same thing. Let's get rid of that little blip there. Okay. All right, so now if we look at our graph here, we could find our slopes. Notice here pi halves, so but negative pi here, so notice it's going to kind of do that again, right? So here we have a slope of 0, right, which is why negative pi was 0. Actually, I'm going to make that in a nicer color, and I'm going to put that point on the graph. So that's 0. So we have, oh, I should enable it again. So this is negative pi halves, pi halves, and pi. And this graph, so the red graph is y equals cosine x. The green graph is the slopes. of y equals cosine x. Or I can just put y equals the slopes of cosine x. All right, so let's get the rest of our slopes here. Negative pi halves, right, looks to be like a slope of 1. Right, a little bit of an eyeball there. However, I'm telling you it's 1. So now I'll make it easy for you. So negative pi here was 0. Negative pi halves was 1. All right, it's 0. We got that relative max there. Right, so this is 0. Pi halves, right, same magnitude as the slopes the same magnitude as negative pi halves, right? But now it's just negative, right? So this is going to be negative 1. And then pi is going back to do the same thing again. So it's looping up to continue this pattern forever and ever and ever and ever and ever and ever. And so that's 0. Let's connect our points. I think I've seen that graph before. I just can't think of what it is. Now let me think. All right, so who would possibly have 0, 0? And then let's draw this out on a unit circle here. So it starts off at 0, 0. And then at pi halves is 1. And then over here it's 0. Oops. Not that way. It's the point pi 0. Right, and then over here, right, it's going to repeat this, and now it's going to be 3 pi halves, negative 1, which would be the same as if I went this direction as negative pi halves. Gee, what function was that the points to? Well, you know, I think that y equals the slopes of cosine x, that looks a whole lot like y equals sine x, doesn't it? Right? Sine x starts at 0, and then it goes to, oh, but wait a minute. It doesn't go to negative 1. No, this is sine x. It looks so much like sine x, but not quite, because sine x is going to come up here. And then it would go over here, right? So it's at 0, 0, then pi halves 1, not pi halves negative 1. And then negative pi halves, it would be at negative 1. And then it would go to 0. So what happened to my sine graph? So the blue graph here, that's y equals sine x. What did we do to our blue graph to get the green graph? Looks like we reflected it over the x-axis. Now what would we have to do to y equals sine x to get it to reflect it over the x-axis? We'd have to make it y equals negative sine x. And so y equals the slopes of cosine x. That's just y equals negative sine x. And now you know the derivative for cosine, because after all, what's the derivative? The derivative, and by the way, you don't have this in your notes. You have everything else but this. The derivative is equal to the slopes of f of x. At various points. And that's what we found, the slopes. And we can now see that when we graph the derivative, so this here, by the way, not only is that green graph y equals negative sine x, that's also the derivative. So if we were to take the derivative of cosine x, that would equal negative sine x.